Hello, my name is Jim Noble and I look after secondary maths at the International School of Toulouse. I wanted to make my video about what I will call one-question lessons for the sake of argument. And by that I mean the sorts of lessons where the formal input of the teacher is limited to a simple, the expression of a simple, concrete task at the outset, which is going to occupy students for the rest of the lesson. Mathematical task design has always been my thing. I think one of the most fascinating bits of the job and one of the things that gets me out of bed in the morning, and inspired in many ways by this book by John Mason and Sue Johnson Wilder, Designing and Using Mathematical Tasks. Highly recommended. Anyway, it's not to be confused with low preparation lessons, because for this sort of thing to work, the task has to be carefully charged with some key elements. Firstly, you've got to have a task that's really easy to understand, an end goal that everybody gets. Secondly, it's got to be conducive to motivation. People have got to want to do it. It's got to grab people as something, oh, I'm going to have a go at that. Thirdly, it needs to have built-in possibilities for students to test their conjectures and get feedback, challenge their misconceptions and get feedback. And lastly, there need to be possibilities built in for discovering some profound bits of mathematics. And so that's a fairly tall order for something that you can express in one task. So I'm going to have a go at exemplifying it with one task that I call making cones. And here we go. I'm going to explain the task really simply. I've got some examples here. The task is simple. Can you please make me a cone that has a base radius of 10 centimetres and a perpendicular height of 24 centimetres out of, and this is really important, a piece of A2 card or paper. Okay, there we go. So that's the task. It's easy to understand. I think everybody understands that we've got to have a result of something that looks a bit like this. We're trying to make one of those, or one of these. Don't know how it's going to look like, or one of these. It's going to be a cone at the end. Secondly, I've asked students to cut out bits of paper and glue them together to make 3D shapes, and I haven't come across a class in my career yet that doesn't want to do that, so it ticks the motivational box there. Well, I want to have a go at that. Thirdly, and this is where it gets really nice, we're into, where does it have this opportunity for people to discover things? Well, let's start with something simple. What is the net of a cone? And a lot of people want that to be a triangle. And one of the best ways to find out if you're right is to cut out a triangle and see if you can fold it into the net of a cone. And you're going to get your feedback from that straight away. So that's just a little example there of the third point I was making when describing the task. So often what happens is that a little experimentation goes with that, and eventually students work out that, or adults have done it with adults too, that the shape needs to be what's often referred to as a Pac-Man for the curved surface of a cone. And then the big question is, okay, so how big has this Pac-Man got to be? What's the radius of the Pac-Man got to be? And what's the arc length of the Pac-Man got to be? And that's where we really get to the crunch. And often we get some fantastic reasoning going on between students. And the teacher is often the observer, around to answer some questions carefully, to ask some questions of some students, to help them clarify their thinking as well. A lot of things go on once we've got that Pac-Man thing decided. Of course, you can work out the radius of the Pac-Man through Pythagoras theorem. So it's a wonderful moment when students work that out and they say, oh, with Pythagoras, this makes sense to me, I can do that. And then they've got to work on the arc length, and so often people want the sector of the circle to be more than half. And then they work out that it doesn't fit on the A2 piece of paper if that's the case. So they've got to check that preconception that they've got and rethink and maybe work out that the Pac-Man's actually going to have a really, really big mouth that makes him not look like a Pac-Man anymore. And that's testing these kind of boundaries of these constructions that you think ought to look a certain way but could also look another way. Anyway, the long and short of it is that you get this kind of lovely reasoning that helps people make relations between the arc length, the curved surface area and its properties, and the base and the height, and see that they're all beautifully related in this lovely exploration. You've got reasoning, you've got exploration, and by the end of the lesson you've got a number of cones that look like this, and what you've had is this great journey into the properties of a cone, which you won't ever get by just learning that the area of the curved surface is pi RL. Anyway, I've tried to give a really quick snapshot of this one question lesson idea, and I've written a blog post to support this video with some links to other similar activities that I think tick that box and do so much for me exemplify so much for me about what's really important in mathematics education.